Welcome to the Godot BootCamp lesson on requesting global entities by indexed ID. In the previous lesson, we created 4 global entities on the design portal that will be used in this lesson. In the Godot example game, we're going to request the list of global entities using their indexed ID. In the API reference, let's take a closer look at the getListByIndexedID request. We can see that we need to supply 2 parameters, the entity indexed ID and the max entities to return. Taking a look at the JSON response example, we can see that an array of global entity objects will be returned. Since we've already ran this request in the Cloud Code API Explorer, we're going to jump right into coding. Open Visual Studio Code and navigate to the constants.cs file. Declare a constant for the global entity's indexed ID. Save the file and then navigate to the leveldata.cs file. This class is responsible for keeping track of the level control data used by the spawner for both endless and horde game modes. Scroll down and declare an overloaded public constructor that takes in the entity type, entity ID, level index, and a reference to the level data dictionary. In the body, initialize the entity type, the entity ID, and the level index member variables. Then declare 3 lists to hold the enemy types and the starting asteroid and enemy types. The rest of the constructor will parse the JSON data from the level data dictionary. All the values that are parsed will be used by the spawner class to spawn asteroids and enemies at the appropriate speed and intervals. Save the file and then navigate to the network.cs file. Declare a pair of public callback delegates that will be used to handle the getListByIndexedID response. Scroll to the bottom and above the output log method, declare a private method called parseLevelData. This method will take in a reference to a dictionary of entity data. In the body of the method, safety check the entity data. Then parse the entity array from the entity data dictionary. Declare a list of level data objects, then declare some local variables. Loop through all the elements in the entity array. Get the entity root dictionary. Parse the entity data and level data objects. Then parse the entity type, entity ID, and the level index. Create a level data object passing in the entity type, entity ID, the level index, and the level data object in as the arguments. Push the level data object onto the level data list. Remember, the level data constructor will finish parsing the rest of the JSON data. Once all the entities have been parsed, return the level data list. In the event that the entity data dictionary was null, return null. Scroll up and above the handle authentication success method, declare a public method called requestLevelData. This method only takes in the callback delegates that we declared a moment ago. In the body, check to see if the user is authenticated. If the user is not authenticated, format an error message and then invoke the handle request error method, passing in the error message and the error delegate as the arguments. If the user is authenticated, declare success callback lambda. In the body of the lambda, log the response data. Then parse the response data and get the entity data object. Invoke the parseLevelData method, passing in a reference to the entity data object as the argument. Finally, if the success callback delegate is not null, it will be invoked, passing in a reference to the level data list as the argument. Next, declare failure callback lambda. In the body of the lambda, format an error message, and then invoke the handleRequestError method, passing in the error message and the error delegate as the arguments. Finally, make the brainCloud Global Entity Services getListByIndexedID request, passing in the level indexed ID constant, the number of values to return, and the success and failure callback lambdas as the arguments. Save the file and then navigate to the game.cs file. Scroll all the way to the bottom of the file. Declare a private method called onLevelDataRequestCompleted. In the body of the method, invoke the spawner setLevelData method, passing in a reference to the level data list as the argument. Set the level count member variable. Then loop through the level data list and get the level data durations and descriptions for each level, and store them in the respective member variable list. Finally, hide the connecting dialog and show the main menu. In the onLeaderboardRequestCompleted method above, delete the else statement and its contents. We are now doing that logic in the onLevelDataRequestCompleted method instead. Scroll up and find the onAuthenticationRequest method. Find the request leaderboard invocation and then delete the second argument. Next, invoke the network's requestLevelData method, passing in the onLevelDataRequestCompleted method in as the argument. Save the file and then navigate to the main menu dialog.cs file. We're going to modify the onShow method to enable the Horde Mode button if the user is authenticated with brainCloud, and disable it if the user is not authenticated with brainCloud. Save the file and then compile the code. If the code compiles successfully, open the Godot editor. Run the game. From the main menu, select Horde Mode, then select Level 1. The asteroids and enemies are spawning based on the global entity data that we created for Level 1. To save time, the playback has been sped up for Level 1. Level 1 is complete, on to Level 2. The playback speed will not be sped up for Level 2 so that we can compare it with a future playthrough of Level 2. On the first playthrough, we didn't even survive for half the required time. Perhaps we made this level a bit too difficult. Open your web browser and navigate to the brainCloud design portal. We're going to tweak some values with the Level 2 global entity. From the dashboard, click Global, then Global Data, followed by Global Entities. Click the Filter by Type box and select Show All Types. Click the Level 2 global entity, then click the 3 vertical dots, then click View Edit. Click Edit. We aren't going to change the asteroid data, but we are going to make a few changes to the enemy data. We'll change how many enemies spawn at one time, modify the min and max spawn times, lower the max enemy speed, and most importantly, we'll remove that pesky fourth enemy with the automatic blasters. Click Save, then return to the Godot editor so that we can test these changes. Run the game, and when connected, select Level 2 from the Horde Mode dialog. The playback speed will not be sped up so that you can compare the previous playthrough of Level 2 if desired. Playing through Level 2, I think we might have actually made it too easy. But that's okay, we can always go back on the brainCloud design portal and make tweaks to our level data at any time. And as you saw in this lesson, we didn't have to change any client code. How to set up user statistics is the next lesson in the Godot BootCamp.